Now we have an important part of panel data analysis. What's that? The topic is that in panel data, which regression we need to use. We need to use panel data analysis or pooled data analysis. In panel data analysis, we need to use fixed effect regressions or random effect regressions. Which one? Then we need to use some another tests to select or prefer one of these regressions. Then in the first step, I use Stata codes to check about pooled or panel data set. Now we need to write x2reg dependent variables, and finally write fixed effect. Okay. In other words, I want to use f as to check about individual specific effect. Means is significant individual specific effects or not. I copy this code, paste here and click enter. This is f-test that used to select or prefer between panel or pooled datasets. If you reject null hypothesis, you need to use panel datasets. You don't need to pool your datasets to use OLS, ordinary least squares regressions. And I'll write here that if test was not significant, it indicates that the individual specific effects are not significantly different from zero. Or we can use OLS regressions. But now for my datasets, null hypothesis rejected and can conclude that the panel dataset is suitable for my datasets. But another step is to select or check about fixed or random effects. We use Hausman tests to check about fixed or random effects. Null hypothesis is that use random effects. To do this, we need to fit fixed effect regressions and also random effect regressions, then store reports of these regressions with this code estimate store fe and estimate store re, then use Hausman fe and re to check about these assumptions. And then I copy this, paste here, and click enter. Okay, dear friends, this is codes check about fixed effect regressions, and I stored fixed effect results. Then I fit random effect regressions and also stored results, and finally Hausman FERA. Hausman test reject null hypothesis. I say that zero hypothesis is that random effects is suitable, but difference in coefficients are not systematic. And for my datasets, since I reject null hypothesis, it's better to use fixed effects. Now, if I want to have a conclusion about my dataset, so I can say that I prefer panel datasets to pooled datasets, and in panel data analysis, I preferred fixed effect regressions and not random effect regressions. Okay, since we done most parts of panel data analysis, and now we know that we need to fit fixed effect regressions and then check about some another assumptions for results of regressions. But what's that? For them, I run fixed effect regressions another time, and this is result of my regressions. Fixed effect regressions, and this is significant relationships for some of variables. But what's another assumptions? Which assumptions to be checked after fit the models? After you fit the models, you need to check about homoscedasticity or heteroscedasticity of variance. You can do this with Leven test or Breusch-Pagan test. Since I used Leven test sometimes ago, now I want to use Breusch-Pagan test to do this. Then you need to have a regressions and then write E-stat het test, means heterogeneity test. Okay. Now we see that null hypothesis rejected. Null hypothesis is constant variance, and this Breusch-Pagan test, similar to Leven test, said that we have heteroscedasticity in variance. But another thing to be checked in your regressions is the correlation or serial correlations. The correlations or serial correlations in panel data, in residuals of your regressions, since we have a time series and panel data data sets, maybe my residuals have some degree of correlations. Then you need to check this assumption with Walderage tests. To do this, in first steps, you need to check, you need to introduce your panel datasets. If you not introduced before, you need to write xdset state year, and another time you need to write xd serials to check about the serial correlations in your residuals, and write your dependent variables and independent variables. I copy these codes, go to Stata and click enters. Now we see that we have serial correlation in your datasets. Now we are in a important and historical parts of this tutorial. Now we have regressions that have heteroscedasticity invariance and also serial correlations. Maybe a few teachers or a few researchers or a few analyzers are there that point this important note. Note is that when you have serial correlations and heteroscedasticity invariance, how to analyze your datasets, how to write data codes. To do this, you can use some steps. For example, to correct for both heteroscedasticity and autocorrelations, you need to use clustered robust standards error or residuals. Oh, okay. And to do this, if you need to use fixed effect regressions, you write this code x2reg dependent variables, your independent variables, fixed effect or random effects, then write VCE and in parentheses write cluster for serial correlations and write state and click on enter. Now this regressions is robust about heteroscedasticity and serial correlations. There is another format of regressions when you have heteroscedasticity and serial correlations. If I wanted to review this, you can use generalized least squares. To do this, you need to write these codes. XTGLS means XT generalized least squares. Your dependent variables, your independent variables, and write panels. Heteroscedastic means heteroscedasticity in variance, and also curve for serial correlations, PSAR 1. Copy this, paste here, click enter, and this is a generalized least squares that robust about heteroscedastic and serial correlations. But another regressions you can use is to use the Driscoll-Kraay standard errors. To do this, you need to install this package net install st0128.pkj. Then to fixed effects and also to random effects, you can use these codes, but I check about random effects and Stata reported are not recognized. Copy this, enter, and we see that Stata reports results, but when they write here RA means random effects, Stata say that option RA means random effects are not allowed. Then you can use these steps. Alright, here that the XTSCC command is designed for use with pooled OLS and fixed effect models, but it does not support random effects models. XTSCC is this code. Then you can manually correct the standard errors in random effects model with this code. Copy and paste here. Now we see that results is reported with Stata. But if I want to summarize these tutorials, in these tutorials I speak about panel datasets. What's the difference between panel and cross-section datasets or time series datasets? And I tried to describe and summarize and how to introduce your datasets as panel datasets and how to change the format of panel ID from string to numeric and how to show your datasets with plots and with tables and also which assumptions needed to be checked for panel datasets. For example, the co-integration and stationary in mean, stationary in variance, and also how to prefer pooled or panel data analysis and how to select between fixed effect or random effects. And after fit the model, how to control about heteroscedasticity serial correlations. Okay, difference. I'm a freelancer and it's more than 6 years that I use Stata, R, SAS, SPSS, and other statistical programs to analyze datasets, especially datasets in economics. For example, panel datasets or time series datasets. Then if you have any class projects, paper analysis, or thesis, you can send your projects, your data sets, your assignments to me in WhatsApp or another programs, and I receive your data sets, survey about this, and write you conditions to do that. And now, until another statistical tutorials. Have a nice day. Goodbye.